How do we solve questions on distance bearing problem? This is what we'll be looking at in this very lesson. If you have not subscribed to the channel, kindly do so for more interesting episodes to come. To solve questions on distance bearing problem, there are three key important concepts that you have to know before you start solving questions on distance bearing problem. These concepts are: so these are the key things that you have to know before you start solving questions on distance bearing problem. Now the question is, when and how do we use each one of these theorems or rules in solving questions on distance bearing problem? When a calculated angle within the diagram that you have drawn, which is sure going to be a triangle, is equal to 90 degrees, then we go for what? Then we go for the trig ratios or the Pythagoras theorem. When a calculated angle within the diagram that you have drawn, which is surely going to be a triangle, is equal to 90 degrees, we go for the Pythagoras theorem or the trig ratios. But when a calculated angle within the diagram that you have drawn is not equal to 90 degrees, then we go for what? The sine or cosine rule. To get an in-depth of what I'm saying here, let's go through this example on the board. So we are saying that a ship sails from port R on a bearing of 65 degrees to port X, a distance of 54 kilometers. It then sails on a bearing of 155 degrees from port S to port Q, a distance of 80 kilometers. We want to find correct to the nearest whole number the distance between R and Q, and then the bearing of Q from R. So this is our question, and we are going to solve it. So in bearing, the first thing that you're supposed to do is to draw your cardinal point. So we have, this is our north pole, this is what? Our south pole, this is our east, and then this is our west. We have already established in our previous lesson that in bearing, angles are measured from the dot in a clockwise direction. So the bearing of 65 degrees is going to fall in this particular quadrant. So you start measuring from the north in this direction. Then we draw our line. A ship sails from port R. So from R will be here on a bearing of 065 degrees to port S. So to port S is going to be here. So this is port X. A distance of what? 54 kilometers. So let's go through the first part. A ship sails from port R to port S on a bearing of 065 degrees, a distance of what? 54 kilometers. That is the first part. It then sails on a bearing of 155 degrees. It then sails on a bearing of what? 155 degrees. So from here, it then sails on that very bearing. So we are also going to draw our cardinal point here. This is still our north pole, our south, and then our east, and then west. We are going to start measuring from the north pole. So we have this, and we know that 155 will fall in the second quadrant, right? So it's going to fall here, and then we draw our. Now remember that the distance given is what? 80 kilometers, and we know that 80 kilometers is longer than what? 54 kilometers. So this line or this distance might be longer than this line because 80 kilometers is longer than what? 54 kilometers. So we can end here, and the distance is what? 80 kilometers. So from port S to what? Port Q. Now let's join this out to what? So let's go through the question again to see if this diagram is in line with the question on the board. A ship sails from port R to port S on a bearing of 065 degrees, a distance of 54 kilometers. It then sails from port S to port Q on a bearing of 155 degrees. So we have 155 degrees, a distance of 80 kilometers. So it means that this diagram is really in line with the question on the board. Once you are done with the diagram, we move to what I call the transit point. In this diagram, our transit point is at what? X. Because when the ship reached port X, it rested for some time before it took another journey to. So to find this angle, the transit angle, we are first going to find this angle, and then we sum them together. So in finding this angle, we are going to apply the alternate angle concept, which says that when you have two power lines being intersected by a transversal line, angle properties are being formed. And one of them that we are going to use is the alternate angle, which says that the angle formed here is equal to the angle formed here. So if this angle is 100 degrees, definitely this angle is also going to be 100 degrees. So we are going to apply this concept to find this angle. So from here, we can see that this angle alternates with what? This angle. Therefore, this angle is equal to 65 degrees. Now let's move on to this particular angle. We know that the measure from the north to the south pole is what? 180 degrees. And we know that the measure from the north to this terminal is 155 degrees. So to find this small angle, we are going to subtract 155 degrees from 180, and that is going to give us what? 25 degrees. So this angle is 25 degrees. Now once we find these two angles, let's sum them to see whether we are going to get a 90 degrees or not. Now we have 65 degrees plus 25 degrees, that gives us what? 90 degrees. So it means that this transit angle is equal to what? 90 degrees. And whenever you have a triangle with one of the angles being equal to 90 degrees, we can use the Pythagoras theorem or the trigonometric ratios. So for us to see it clear, we are going to redraw this triangle. The 90 degrees is at port X, so we have port X, we have port R, and then Q. Now let's add the dimensions. We have RS. RS is what? 54 kilometers, so we have 54 kilometers. And then we have RQ. RQ we don't know, so let's use any variable at all. Let's say variable X. And then we have SQ. SQ is what? 80 kilometers. Now this diagram is the same as this right angle triangle. Since this is a right angle triangle, we can apply the Pythagoras theorem to find the distance between R and then Q. So we are going to apply what? Pythagoras theorem. So the theorem, it says that the square of the hypotenuse is equal to the sum of squares of the other two sides. So we have 54 squared plus 80 all squared. So we have our s squared is equal to 54 squared plus 80 squared is going to give us 9316. Now we are looking for s, so we take the square root on both sides. We have our s is equal to 96.5 kilometers. So the distance between R and Q, which is x, is equal to what? 96.5 kilometers. Now let's move on to the next question. We want to find the bearing of Q from R. So to find the bearing of Q from R, we are going to start measuring from the north in a clockwise direction till we get to this particular line. In that case, we have to find this angle and then we add it to this angle to give us the bearing of Q from R. Now we know that angle theta is at R. Theta is at R, so we are going to place the angle here. We have angle theta. Now once we have this, we can apply the trig ratio to find angle theta. We know that tan theta is equal to opposite all over what? Adjacent. The opposite from this triangle is what? 80 all over the adjacent, which is what? 54. So we have our tan theta is equal to 80 over what? 54. So to find angle theta, we are going to take the tan inverse of this number. So we have angle theta is equal to tan inverse of what? 80 all over 54. And this is going to give us 55.99. So you can say that our angle theta is equal to 56 degrees. Now the question says we have to find the bearing of Q from R. Now we know that angle theta is equal to, so the bearing of Q from R is going to be the sum of this angle and then this angle. So we are going to have 65 degrees plus what? 56 degrees, and that's going to give us 121 degrees. So this is I, and then this is what? I. As easy as that. This brings us to the end of today's lesson. See you tomorrow. Bye bye.